So what we are finding, so this planet K218b is a planet that's about 8.6 times Earth mass and about 2.5 times Earth radius. So it's a big planet. And what we are finding is uh, hints of potential biological activity on the planet. How do we establish that? We are finding hints of one or both of two molecules, DMS and DMDS. DMS stands for dimethyl sulfide. DMDS is dimethyl disulfide. Now, both these molecules on Earth are known to be produced uniquely by life and organic matter in general. Mostly microorganisms in the Earth's oceans, for example, produce a lot of DMS, most of the DMS. Now, it has been predicted over the last couple of decades that those are the kinds of molecules that would be unique signatures of life on exoplanets when you're looking at these planets beyond the solar system, both for Earth-like planets, but also for planets with hydrogen-rich atmospheres, like the planet that we're talking about, K218b. And what we have found is like evidence for at least one or both of these molecules at a 3 sigma significance. 3 sigma means it would be, you would still have 0.3% chance that it's a statistical fluke, for example. So 3 in 1,000 chance of it being a fluke. Now, usually that is considered good. It's a respectable detection significance. But when the result is of this significance, this big, you want to be really, 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 really sure. So we want to make more observations to increase our confidence in the findings. But if confirmed, then this would be a very good candidate for being a biosignature or on another planet outside the solar system.
Definitely, sir. So based on your study, does this suggest that life could exist on other planets as well? And if yes, what kind of life are we talking about? Are these microorganisms, are these plants, or something else?
Yeah, so this had been predicted. We had predicted over the last 5 years. We have been studying this planet both theoretically and observationally, and it has been predicted that if life exists on planets like this, they should give out emit molecules like DMS and DMDS. Both us and other people have also said this over the last 2 decades in various contexts. So the baseline assumption for this kind of emissions, molecular emissions, is microbial life, because that's what the source is on Earth. Mostly microbial life is what produces these gases. So we are expecting that if this molecule is indeed due to life, the nature of that life would be mostly microbial. We don't know if there would be complex life or not, but that is completely unconstrained at this point. We are operating with a very baseline simple assumption that the very simplest form of life, microorganisms, should be able to produce these gases as we know here on Earth.
Definitely, sir. So could you please tell us how molecules like DMS, DMDS were detected on K218b and why these
Yeah.
gases are considered potential indicators of life?
Yeah. So DMS, so these molecules are detected like any other molecules in exoplanetary atmospheres. The technique we use is called transit spectroscopy. What happens is that you're looking at the star and you get a stellar spectrum. You look at a star through a telescope, you get a spectrum, the distribution of light as a function of wavelength. However, if you have a planet going in front of it, it's called a transit of the planet in front of the star, like the transit of Venus, for example. Then some of that starlight passes through the atmosphere of the planet before reaching the telescope. And when that happens, the molecules in the atmosphere of the planet absorb some of that starlight, depending on the wavelength, because the molecules have different absorption features, spectra as a function of wavelength. So with that observation, taking the difference between when the planet is not in front of the star and when the planet is in front of the star, the difference of that can tell you what is the actual absorption being caused in the atmosphere of the planet. Once you have that, that is what is known as a transmission spectrum. And then we can look at that spectrum and establish what are the various molecules in the planet's atmosphere that are causing those absorption features.
Sure, sir. Sure. And as you also mentioned in the beginning, sir, that that this study has 99.7% confidence level in detecting these gases. So, sir, in simple terms, how strong is this confidence, and what more needs to be done before confirming anything about life?
Yes, I mean, this is called a 3 sigma result where you have a 99.7% confidence. So it is moderately strong. It is respectable, but this is not that is not the confidence where you would say that I'm absolutely sure that the molecule is there, especially when the results are so impactful, like this one that has the potential to be so impactful. You want in science, in physical sciences at least, when you have big breakthroughs, big paradigm shifts, you want to be really sure, because it changes the very fabric of science and society in fundamental ways. So then the measure of robustness there is that we want to be sure to a level that there is less than one part in a million chance of a fluke, which means very small chance of a statistical fluke, or by chance, error by chance. So that's what we're talking about. We want to be that robust.
Sure, sir. And sir, we have come to understand that K218b is also called a Hycean planet. Sir, could you
Yeah.
explain in simple terms what a Hycean world is and why it
Yeah.
is considered a good candidate for the search of life?
Yeah. So a Hycean world is a planet with an ocean-covered surface and a hydrogen-rich atmosphere. So the word Hycean stands for hydrogen and ocean. And this is a term that we coined 5 years ago. This is in my team. We came up with this concept of a Hycean world because we tried to find planets which could be habitable and still are big enough and have the properties that are observable with current facilities. So we came up with this concept, and K218b is a good candidate for that. If you take the mass, radius, equilibrium temperature of the planet, it matches that description. More importantly, just 2 years ago in 2023, we made our first JWST observations of this planet, and we found molecules, carbon-bearing molecules like methane and CO2 in the atmosphere of this planet for the first time. And we did not find some other molecules like ammonia and carbon monoxide in this planet. Now, that combination has already been predicted even before the observations were taken, that is what you would see if there is a Hycean world with an ocean and a thin hydrogen-rich atmosphere. So the observations confirmed the theory, and that's why we think this is a good candidate for being a Hycean world. Obviously, we want to remain open to other possibilities, but so far, that is our best understanding, that this is a good candidate, and therefore we should keep observing it.
Right, sir. Sir, as you said that you want to be open for other possibilities as well. So, sir, could discoveries like this eventually mean that human life might exist somewhere else in the universe, even if not necessarily on K218b?
Yeah, so that is the paradigm shift we are talking about here, in the sense that if these results eventually indicate that it is due to life, then what that is telling us is that the universe must be teeming with life. Life must be very common in the universe. If we are able to find in one planet, we should be able to find in other planets as well. And so that is like a big implication of these results. Obviously, we are not there yet. We are not claiming that we are detecting life right now, but the very fact that we are able to detect these molecules means that we have the capability to detect them on planets like this, which means it's a major step forward for us as a species, not us as a research group or scientists or one community or the other. It is it is a signal that we as a species have come ourselves from very simple microbial life to an advanced civilization where we have developed the tools like the James Webb Space Telescope, which can peer into the cosmos and detect molecules like this on habitable planets. And to me, like, that's a major technological shift. And then if we eventually detect life out there, we will look back and see this is the moment when our journey has actually started.
Sir, a follow-up question on this, that if we eventually detect that, like if that confidence becomes 100%, how could that change our overall understanding of how common life might be across the universe?
Yeah. So, I mean, it is entirely possible that if we spend a few more observations on this planet in a few years, we may be able to increase the significance substantially and very confidently detect these molecules. Now, from a scientific point of view, it has a major repercussion in the sense that if we can establish that K218b is habitable and has life on it, then that means that life must be very common in the universe, because there are lots of planets out there. I mean, maybe not very common, but it's still common. If you find it on one planet, you can make the argument that you could find it on others too, because there are so many planets out there. But more importantly, it has a fundamental impact on how we think about the night sky and how we think about the universe, right? Because today, for example, if you look out in the night sky, your impression of the sky is the universe out there, a physical universe with physical objects like planets, stars, galaxies, and so on. But it's still a physical universe, whereas we are the biological part of the universe being on Earth. But if you detect life elsewhere, that changes that paradigm, because when you look at the night sky, you'd be thinking of it as a living sky. And that very act transforms you from a society that is Earth-based, a civilization that's Earth-based, to a very cosmic entity, right? So you suddenly realize that we are actually biologically sharing this universe with other planets and other species, and that is a fundamental shift in how we look at the universe and our place in the universe.
Definitely, sir. That living sky thing can completely change our perspective. Sir,
Exactly.
moving on, this is the last question. So, sir, what are the next steps for confirming these findings? Like, are there more telescopes or more missions coming up that will help us understand the K218 better?
Yeah, so even with the James Webb Space Telescope, which is a huge technological marvel, right? We should all be very proud of what we have as a species could accomplish with this telescope. I think even with the James Webb Space Telescope, we could look at K218b for a lot longer, many more such observations, and that will increase the information we have about the planet, its atmospheric composition, and if there is any variability in the atmosphere. We can look at all of those things even with the James Webb Space Telescope. And in the future, if we have other telescopes like the planned Habitable Worlds Observatory that is being planned right now, then we could look at Hycean worlds or candidate Hycean worlds that are even farther from the star and look at the reflection spectra and can also say something about their atmospheres. So I think there is a lot of promise observationally, because these planets are our best bet currently in the search for habitable conditions and life elsewhere.